Okay, visible as well. My screen is visible to you guys. Yeah. Okay. In the last lecture, we had started our exercise 6.2. Yes or no? Yes, we had started exercise 6.2, and we are continuing that exercise now as well. In last one, we had done exercise 6.2 up to question number 4, I guess we had completed, and then we have to start with the exercise 6.2 question number 5. I hope I have first to fourth question is clear to everyone. Is there anyone who is having any doubt related to first to fourth question? Anyone is having any doubt? Okay, no doubt. I think Neville is the only participant in this class. What about rest everyone? Okay? No one is having doubt. Okay? Nishta says no doubt. What about rest? Okay, hers is also having no doubt. So I think now I can say everyone is almost clear with this. So we have to start with a question number 5. In a question number 5, it says like this. One of the figure is given like this. Here A, then another one is, PQR, it's given like this. Here P, then here it's a Q, and here it's R. PQR is given, and here one of the point PO is here. So I'm just drawing here PO. This is O, and this is point O to R. Okay, and DEF, it's also given. So here I'm taking EF, and here I'm taking the point D and F. Okay, so this is the figure given to us. In figure 6.20, DE is parallel to QO. This DE and this QO, that is parallel given. Okay, and DF is equal to OR. These two are also parallel. These two things is given to us. DE is parallel to OQ, and DF is parallel to OR. These two things is given to us. Now, we have to prove EF is parallel to QR. These two is parallel, that we have to prove. Okay, so let's start. This is given to us, and we have to prove EF is parallel to QR. Now, whenever we have to prove this something which is parallel, at that time what we have to do? Whenever we have to prove this parallel, then we have to use converse theorem. When parallel is given and we have to prove the ratio, then what we are doing? Then at that time we are using BPT. Now here, if we have to use the parallel thing, then we have to use converse theorem. Now, if we want to use converse theorem, then first of all ratio should be equal. That ratio we can prove using this two, because parallel is given. If parallel is given, then what we can say? Out of this we can use BPT, and from BPT we can just say that ratio would be equal. So proof, I am just starting. See, if I am taking DE is parallel to OQ, so this would be the triangle POQ. So I can write in triangle POQ, this triangle POQ, it's given DE is parallel to OQ. DE, this DE is parallel to OQ. So now we can write by BPT or theorem 6.1. What we can say? So it's a DE it's a PE upon EQ. It's a PE upon EQ is equal to, I can write this PD upon DQ, DO, PD upon DO, and I am saying this as the equation number 1. Okay. Same way, if I am talking about this triangle POR, so DF is parallel to OR, that is given DF is parallel to OR. So I am just writing this one in triangle POR, this is the triangle which is given to us, where DF is parallel to OR, that is given to us. So I can write, so by BPT, basic proportionality theorem, this PD upon DO, PD upon DO is equals to PF upon FR is equals to PF upon FR, and I am saying this as equation number 2. Okay. So from equation 1 and 2, I can write from equation 1 and 2. This two things are equal. So one is equal to same, second is equal to third, then first and third are equal. So I can write PE upon EQ is equals to PF upon FR. So it's given this PE upon EQ is equals to PF upon FR, that is given to us. So now what I can write here, PE upon EQ is equals to PF upon FR. So by converse of BPT, basic proportionality theorem, I can write PE or EF is parallel to QR, hence proof. अगर ये दोनों रेशियो इक्वल हो जाते हैं, that means ये दोनों साइड पैरेलल हो जाएगी. So I can write like this: EF is parallel to QR, hence proof. Is there anyone who is having any doubt in this one? Hello? Any doubt? Any one of you having? Okay, I'm just repeating this one. See, these two sides are parallel. So I can make triangle like this, where P, here DF is there, D, and here it's E, and here Q and O is there. If these two sides are parallel, then you use theorem 6.1. PE upon EQ is equals to PD upon DO. So that is why I had written PE upon EQ is equals to PD upon DO, because this is given to us. Same way, if I am talking about these two triangles, this triangle POR, then it's like this: PO, and here it's R, and here point D and F is there. So this DF is parallel to OR. So PD upon DO is equals to PF upon FR. PD upon DO is equals to PF upon FR. So I had written this to second one. Now both having a left hand side are equal, then PE upon EQ is equals to PF upon FR I can write. Now just forget this thing. So this PE upon EQ is equals to PF upon FR, that is given. PE upon EQ is equals to PF upon FR. Then by converse of BPT, BPT का converse theorem से what we can say? अगर ratio same होता है, then these two are parallel. So I can write EF is parallel to QR, hence proof. First, is it clear now?
Yes, sir.
Okay. Anyone else having doubt? Or else you can take a screenshot as well. Now let's move to the next question. Question number 6. And beta, please do every day's work regularly. Now question number 6, it says in figure 6.21, हमारे पास next figure है, figure 6.21. So let's first draw this figure 6.21. It's like this. So I'm just drawing this figure, figure 6.21 in this one. Okay, figure is like this, in which ABCPQR is given. A, B, C, P, Q, and R. This point are there, and this is O point. It's like this. Sorry, I have just done this thing differently. P, Q, R. This should be over here. P, Q, R, and here it's A, B, and this one is C. A, B, C point is there. Now, what is given to us? A, B, C are points on OP, OQ, and OR respectively, such that this AB is parallel to PQ. These two are parallel. Same way, another thing is given. What is given to us? Let us write given. AB is parallel to PQ. This is given. Rest, what is given? It's given AC is parallel to PR. This AC is parallel to PR. It is given also AC is parallel to PR. And the next one is BC is parallel to QR. That we have to prove. It's like question number 5 only. Nothing is changed. I'm just explaining to you that what we are going to do. But you have to write. I will not write anything. See, what is given to us? This AB and this PQ is parallel. So we have a triangle like this. Here O point is there. Here A and B are there. And this P and Q are there. So if these two are parallel, then I can write OA upon AP is equals to OB upon BQ. So I'm just writing OA upon AB. AP is equals to OB upon BQ. And I'm giving this equation number 1. Okay. Now, if we are talking about this one, AC is parallel to PR. So we have another triangle like this, where these two are parallel, A and C, and here P and R, and here O point is there. So we can write these two are parallel. So OC upon CR, I can write OC upon CR is equals to OA upon AP. Okay, this is our question number 2, in which these two are equal. So we can compare these two as well. So OB upon BQ is equals to OC upon CR. Okay. Here in this two we had used BPT, basic proportionality theorem. But here now we had derived this one. For this particular triangle, this ratio OB upon BQ is equals to OC upon CR that we had derived. So from this we can write this BC is parallel to QR, hence proved. Am I clear with this? Question number 6. How many of you have doubt? First, we are using BPT. Then second, we are using converse of BPT. In first two, we are just using BPT, and next two or next one, converse of BPT, so that we can prove this one. And once parallel is given, then from that we can use ratio is equals, and if ratio is equal, then we can prove that two sides are parallel. Okay, now let's move to the next question. And if you want to take a screenshot of this, then you can take for your understanding. Now, let's do this. Question number 7. Using theorem 6.1, prove that a line drawn through the midpoint of one side of triangle parallel to another side bisects the third side. What we have to do? Using theorem 6.1, prove that the line drawn through the midpoint of one side of triangle parallel to another side bisects the third side. That was the theorem, midpoint theorem, which we had learned in the last standard, and that we have to prove using this theorem. So let's do this. Here, one of the triangle is given, A, B, C, and one of the midpoint I have to take. So M, I am taking a midpoint, so that this would be divided into equal part. And from M, I am drawing one of the parallel sides to BC, which intersect AC at point N. And we have to prove this AN is equals to NC, or we can write N is the midpoint of this AC, that we have to prove. Again, I am just reading the question and explaining this. It's written using theorem 6.2, using theorem 6.1, prove that a line drawn through the midpoint of one side of triangle. See, this is the triangle which thus one of the midpoint we have to take. So this is the midpoint. We are drawing one parallel line to given side. So कोई भी एक साइड से पैरेलल एक लाइन ड्रॉ कर रहा हूँ, थर्ड साइड को कोई ना कोई पॉइंट पे इंटरसेक्ट करेगा. So this point intersection I had taken, and this two would be equal. That we have to prove, or bisect the third side. That means we have to prove that AN is equals to NC. So I'm just writing this given, whatever is given to us and whatever we have to prove. So I'm writing here given and to prove. In triangle ABC, M is a midpoint of AB. Midpoint of AB. अगर midpoint हो रहा है, so I can write, so AM is equals to MB. I can write AM is equals to MB, or I can write AM is equals to half of the AB, or MB is equals to half of the AB. I can write like this. And MN is parallel to BC, which intersects AC at N. AC को N पॉइंट पे इंटरसेक्ट करेगा. ये भी कर दिया. This two we have to prove that is equal, or we can write to prove N is midpoint of AC. ये प्रूव करना है या तो, और AN is equal to NC. ये प्रूव करना है. बराबर ना? Given and to prove. That you understood, everyone? Just go through it quickly, and if still you have doubt, then you can ask. Just read the question and just see the given and to prove whatever I had written. If you are thinking that I should change, then please say so that I can change as well. It's done, better. Okay. So now proof we are writing. Proof. I can write in triangle ABC. If I'm thinking about this triangle ABC, then which theorem we have to use? I have to use first theorem. So here we have MN is parallel to BC. That MN and BC both are parallel. This MN and this BC both are parallel. So I can write, so by theorem 6.1, I can write this AM upon MB is equals to AN upon NC. I can write like this. If two sides are parallel and which is intersecting two sides, then it is dividing in the same ratio. So AM upon MB is equal to AN upon NC. I can write like this. Now, S AM is equal to MB. Why I am writing this given, or we can write M is the midpoint of AB. So I can write AM is equals to MB. So in place of this I can write MB, or in place of this I can write AM. So I'm just writing that only. In place AM as it is, upon in place of MB I'm just writing AN, and this be AN upon NC would be as it is. Now AM gets cancelled out, so we have 1 is equal to AN upon NC, and this NC goes to opposite side, so we can write AN is equal to NC. Now AN is equal to NC, so we can write N is midpoint of AC, midpoint of AC, hence proved. Again I am repeating, please give attention on this one. See, this is the triangle which is given to us. Out of that it's written that one side passing from midpoint of one side which is parallel to the second side bisect the third side. So एम मैंने मिड पॉइंट लिया, मिड पॉइंट है दैट मींस ए एम इज इक्वल टू एम बी हो जाएगा एंड एम एन इज पैरेलल टू बी सी बिकॉज दैट another side we have to take parallel, so it will be intersecting at point n, and that we had written over here in a given whatever condition is given to us. Now we have to prove that n is the midpoint or bisector here, n bisects AC, that we have to write. That means n is midpoint of this AC that I have to write. So that is why I can write AN is equals to NC. So I had written N is midpoint of AC or AN is equals to NC, that I have to write. For that, it's in this triangle ABC. These two sides are parallel, MN and BC. Both are given parallel. So that is why I had written AM upon MB is equals to AN upon NC. So that is why I had written like this. Now AM and MB both are equal. So that is why I am writing AM is equals to MB. So this two would be equal. So this two get cancelled out and our ratio would be 1. So AN upon NC is equals to 1. So we can write AN is equals to NC. And AN is equals to NC. That means N is midpoint of AC. Hence proved. Is it clear or still you have doubt? Any one of you? Who said MN is parallel to BC? It's given, beta. It's the next question I think you are just seeing. I think you are seeing the question number 8. Santanu. If you have a solution and you are just checking, then it's a 8 questions answer. Okay? And don't see your NCERT solution. Otherwise, it is your waste of time. You can just see the NCERT solution and no need to attend the class. Because whatever I am explaining, that is based on purely theorem, whatever I had explained to you. Sometimes in NCERT solution, some things would be little difficult. That also I am writing here by simplified method. Okay, next question is like that only. See, question 7 is this one. You can take a screenshot. Question 8, just if you are seeing, then it's written, using theorem 6.2, prove that the line joining the midpoints of any two sides of a triangle. Line segment joining the midpoints of any two sides. So this is N is the midpoint and this N is also a midpoint. These two are midpoints. Okay. Prove that line joining the midpoints of any two sides of triangle is parallel to third side. Means in this one, M is midpoint of this one, N is midpoint of this one, and we have to prove MN is parallel to BC. So that is why I am writing over here that we have to prove MN is parallel to BC. That I have to prove. In triangle, M is a midpoint of AC, so that AM is equals to MB. And अब यहाँ पे ये सारी चीजें चेंज हो जाएंगी. And M is midpoint of AC such that AN is equals to MC. Now please go through it once in given and to prove. Anyone having any doubt? Read the question 8 properly and see whatever I had written given and to prove. Is there anyone who is having any doubt? Then please ask. Okay, so now if we are talking about this one, in triangle, if we are talking about triangle ABC, whenever we have to prove that two sides are parallel, that means we are using theorem 6.2, no, ratio would be equal, then two sides would be parallel, that we are going to use. So in triangle ABC, if I want to write AM upon MB, then I can write it as AM upon AM is equals to 1. Why? because AM is equal to MB, or you can write M is midpoint of AB. You can write like this one. ये रीजन मैंने लिखा हुआ है, क्यों यहाँ पे मैंने AM लिखा, बिकॉज AM इज इक्वल टू MB. ये गिवन में भी हो सकता है, or you can write M is the midpoint of AB. So that is why I had written this as the equation number 1. Now, also if I am talking about AN and NC, so if I am finding this ratio AN upon NC, then AN I am putting as it is, but in place of NC I am writing AN, and this would be also 1 because AN is equal to NC, or you can write this as a N is the midpoint of AC. So this is equation 1 and this is equation 2. From equation 1 and equation 2, if we are talking about this equation, then both having the right hand side that is equal. Right hand side is 1. So I can compare this to left hand side. That means I can write AM upon MB is equals to AN upon NC. This I can write AM upon MB is equals to AN upon NC. So by theorem 6.2, we can write these two are parallel. So we can write MN is parallel to BC and screw. Any doubt anyone is having? Then please ask. Santanu, now it's clear? Hello? Santanu, is it clear? ओके, सो बेटा क्वेश्चन पढ़ो, उससे मुझे कोई प्रॉब्लम नहीं है, पर आगे का सॉल्यूशन मत देखो, उससे आपको जो करंटली चल रहा है उसमें ज्यादा प्रॉब्लम होगी, तो वो दिक्कत ना हो इसलिए मेरे साथ ही चलो, बराबर. मैं आपको इतना टाइम दे दूंगा जिसमें आप कहीं भी पूछ सकते हो, कोई भी क्वेश्चन पूछना हो, बट डोंट यूज एनसीईआरटी सॉल्यूशंस. Okay, now let's move to the next question. It's a question number, this one was question number 8, I guess. Okay, you can take a screenshot of this. Now we are moving with a question number 9. In a question number 9, it says ABCD is a trapezium. In a question number 9, it says ABCD is a trapezium in which AB is parallel to DC. This ABCD, A, D, and here C, and here it's D. ABCD is a trapezium. This ABCD is a trapezium in which AB is parallel to DC and its diagonal intersect each other at point O, and its diagonal AC and BD intersect each other at O. And now we have to prove AO upon BO is equals to CO, this CO upon DO, that we have to prove. So how we are going to prove? Anyone wants to try that? Please say to me. If anyone wants to try, then they can say to me. Okay. No one's reply. Okay, no one's reply. That means I have to explain. Okay. So first of all, please give attention on this. This ABCD is a trapezium. Trapezium है और उसमें ये दोनों साइड पैरेलल भी दी गई है. These two sides which are given parallel, this AB and this CD, both are given parallel. Okay. So if I want to take this AO and this BO to be in a ratio, that means I need to check about a triangle. So we can get this triangle, one of the triangle, this one, and another triangle, this one, and if I can compare these two, then from that only we can find this ratio. For that, what I have to do? I have to make one of the lines which is parallel and passing from O. So that what would be there? This line and this line. This, if I am talking about this triangle, then these two sides are parallel and I can take the ratio. And similarly, for these two sides, I can take another part and its ratio also I can take. And from that, we can prove these things. Now, if you want to try, then you can try. Or should I explain this one? Hello? Should I explain or you will do? Okay, let me explain. Just then try. I'm giving you 5 minutes. I'm just giving you a 5 minutes. In this 5 minutes, okay, Neville says I have to explain. Okay, so let me explain this. Or you want to try, then I'm giving you 5 minutes. Choice is yours. What you want to do? Because if you are seeing that you have to divide AO upon BO is equals to CO upon DO, that means first we have to take parallel and use the first theorem, theorem 6.1. I'm just waiting for 5 minutes. So by 8:39, I'll be asking this question to you. Hello, Harsh, please, you can proceed.
सर व्हाट इज द मिड पॉइंट ऑफ एडी? एडी के बीच में क्या लिखा है आपने? एम है ना?
एम है, यहाँ पे मैंने एम अपने हिसाब से नाम दे दिया है, पर वो मिड पॉइंट है ऐसा जरूरी नहीं है बेटा।
सर थ्योरम 6.1 के हिसाब से ना वो मिड पॉइंट हो जाएगा, क्योंकि ना हमने वो लाइन बीच में पैरेलल ड्रॉ की है।
अब यस
बेटा ये
मिड पॉइंट नहीं, देख देख देख, वेट अ मिनट, अभी भी शायद तेरा थियरम 6.1 का कॉन्सेप्ट थोड़ा सा गलत है। ए बी सी, अगर ये दोनों पैरेलल है तो कहाँ मिड पॉइंट हुआ? तो भी ये ए एम अपॉन एम बी इज इक्वल टू ए एन अपॉन एन बी लिख ही सकते हो। ये मिड पॉइंट हो ऐसा जरूरी नहीं है। ओके, ये यहाँ पे एम एन हो तो भी ये रेशियो होगा ही, एम एन ए एम अपॉन एम बी इज इक्वल टू ए एन अपॉन एम सी। तो ये जरूरी नहीं है कि ये मिड पॉइंट ही हो। इज इट क्लियर?
यस सर, तो ना रेशियो इक्वल होगा ना, तो ए एम अपॉन एम डी इज इक्वल टू ए ओ अपॉन ओ सी। सर दूसरा ट्राइंगल की बात करें तो है ना ए
यस यस, यू कैन प्रोसीड।
ए एम इज इक्वल टू एम डी, ए एम डिवाइड बाई एम डी इज इक्वल टू ए ओ डिवाइड
ओके
बाई ओ सी।
ओके, ए एम अपॉन
दूसरे
एम डी
ट्राइंगल
is equal to AO upon OC, means you had taken this triangle. Okay.
then ABD triangle ABD.
Yeah, very good. We have to take this triangle ABD. Then
Sir, then MO and AB are parallel, so
MO and MD
AM and M
yeah.
AM divided by MD is equal to BO.
OB upon OD. You had written directly. Means you are taking this one, this triangle if you are taking. Then OMD upon MA is equals to DO upon BO. So I'm just taking a reciprocal. Okay. In both left hand side are equal, then right hand side also would be equal. So we can write AO upon OC is equal to OB upon OD. And this OB comes here, means just interchange this value. So AO upon OB is equal to OC upon OD, hence proof. How many of you understood this question? Hello? How many of you understood this question? Okay, no problem. I'm just explaining this once again. See, yeah, I'm just explaining this. Whatever is given to us, that first of all let us write given. In this one, if I am writing in quadrilateral ABCD, this is quadrilateral ABCD. AB is parallel to CD. This is given to us, and AC and BD intersect each other at O. This thing is given to us, each other at O. Now we have to prove. This is to prove. That means it's given AO upon OB is equals to OD or OC upon OD. That we have to prove. Okay, OA upon AO upon BO. Sorry, here it's AO upon BO is equals to CO upon DO. That we have to prove. Its meaning is same or only OD or OC, whatever you are taking. अब देखो, ये प्रूव करने के लिए एक थिंग्स मुझे कंस्ट्रक्ट करनी पड़ेगी. सो आई एम जस्ट राइटिंग हियर कंस्ट्रक्ट. ड्रॉ MN parallel to AB parallel to DC. Why I am writing like this? MN is parallel to AB parallel to DC. Because ये दोनों पहले से ही पैरेलल थे. अब ये MN में ड्रॉ कर रहा हूं, which is parallel to AB or DC. So that is why I had written draw MN parallel to AB parallel to DC, passing from O and intersect AD at M and BC at N. ये जितना भी लिखा उसमें किसी को कोई डाउट बेटा? हेलो, अब तक जितना लिखा उसमें किसी को कोई डाउट? फिगर देख लो और फिगर के हिसाब से ही मैंने लिखा है. दिस टू आर पैरेलल एंड सेम वे दिस टू वुड बी आल्सो पैरेलल. अब सपोज इतना पार्ट हो जाता है, देन वी आर मूविंग हियर. अब ये पार्ट मैं आपको बताने के लिए यहां से हटा देता हूं. ओके, ये पार्ट की मुझे ज्यादा रिक्वायरमेंट नहीं है, सो दैट इज व्हाई आई एम जस्ट रिमूविंग दैट पार्ट. नाउ प्रूफ. इन ट्राइंगल ADC, अगर मैं ये ट्राइंगल ADC की बात कर रहा हूं, सो इट्स MN इज पैरेलल टू डीसी। दिस ये पूरा का पूरा एमएन था, वो डीसी के पैरेलल था, बराबर। सो आई कैन राइट एमओ इज ऑल्सो पैरेलल टू डीसी, क्योंकि एमएन के ऊपर ही पॉइंट है ओ। तो हम अगर ये लाइन है मेरे पास ए बी और यहाँ पे सी, तो ए सी किसी के साथ पैरेलल है, तो ए बी पैरेलल टू दिस ऑल्सो वी कैन राइट बी सी इज ऑल्सो पैरेलल टू दिस, बिकॉज यही लाइन के दो तीन नाम हो सकते हैं बेस्ड ऑन पॉइंट। So that is why I had written MO parallel to DC. So based on this, by theorem 6.1, I can write by theorem 6.1, I can write AM upon MD, AM upon MD is equals to AO upon OC, and I'm seeing this as a equation number 1. Any doubt? Any one of you having? Up to this, any doubt? Okay.
No, sir.
No doubt? Okay. No doubt, then I'm removing this part as well. समझाने के लिए मैं बता रहा हूँ. So this MO and AB both are parallel. So we can write MO is parallel to AB. This is given to us. So in triangle, I'm talking about triangle ABD. In triangle ABD, MO is parallel to AB. So we can write DM upon MA. DM upon AM is equals to DO upon DO, DO upon BO. And I'm saying that now if we are want to compare this thing, then here it's AM, this is in a numerator, here it's in a denominator. DM, it's in a denominator, here it's in a numerator. So we have to take a reciprocal of this. So AM upon DM is equals to BO upon DO. I can write like this, and I'm seeing this as the equation number 2. Now if I want to compare these two things, then I can write from equation 1 and 2. AO upon BO, sorry, AO upon CO is equals to BO upon DO. And from this I can write AO upon BO is equals to CO upon DO. Hence proved. Is it clear or still you have doubt? Hello?
Sir, repeat from last.
Santanu, is it clear? Santanu? And what about everyone else? Maitri? Nishtha? Aishwarya? Okay, last. See, ये दोनों इक्वल हो गए, then दोनों की लेफ्ट हैंड साइड इक्वल है, तो राइट हैंड साइड भी इक्वल हो जाएगी. सो AO अपॉन OC, AO अपॉन OC इज इक्वल्स टू BO अपॉन DO. अब इन दोनों को मैं खाली इंटरचेंज कर लेता हूं, क्योंकि मुझे BO यहाँ चाहिए. सो BO नीचे आएगा तो ये CO ऊपर चला जाएगा. AO एज इट इज उसकी प्लेस पे ही है, DO एज इट इज उसकी प्लेस पे है. इज इट क्लियर नाउ, महक? What about you, Ayushi? Anushka? Maitri, that I'll explain to you. First, let the board decide. Nishtha, you got this? Nishtha, you got this? Okay. Maitri, I'll explain this to you, how question would be asked. But let the CBSE clears these things. Then I'll give to you that MCQ as well. Okay, no problem. See, question number 9 was like this. And if you wish to solve this question like another method, then also you can use like this as well. See, ये part इस side का हटा दो, and you can take this two triangle as well. This two, BO upon OD is equals to BN upon NC. You can take like that. BO upon OD is equals to BN upon NC, because these two are parallel. Same way you can take CN upon BN is equals to CO upon OA, and you can compare this, so you will get this answer. Is it clear or not? So this two also we can take now. If we are talking about a question number 10, then question number 10 would be like this only. Just we are thinking that what we have to do. I'll just give you a step and then you have to do it by your own self. See, question number 10 is that the diagonal of quadrilateral ABCD intersect each other at point O such that AO is upon BO is equals to CO upon DO, so that ABCD is a trapezium. We have to prove what we have to prove. So ABCD is trapezium. That we have to prove is our trapezium. For that, in triangle ABCD, AB is parallel to CD, it is not given. AC and BD intersect each other at O. This is given to us. And also AO upon BO is equals to CO upon DO. This is given to us. AO upon BO is equals to CO upon DO. That is given to us. Now, we have to draw that, we can say here also MN is parallel to AB. We are just drawing the line, or you can just write this construction as well. See, this was the quadrilateral, any quadrilateral. Here A, B, C and D, and these two are intersecting each other at O. It's given AO upon OB is equals to OC upon OD. This is given to us. AO upon DO is equals to CO upon DO. So from this I can write AO upon OC is equals to BO upon OD. So I'm just taking this two. Let's draw one of the lines which is parallel to DC. I can just take this OD, or you are just taking this part MO. MO is parallel to DC. I'm just taking this part. Okay. So first step would be this one. Then second step you can take this one, and third step you can take this one. Okay. Hello. For that construction you have to take this construction. This is parallel, one of the sides. So we can write AM upon MD is equals to AO upon OC. We can write like this. Am I clear or not? How many of you are understanding? AM upon MD is equals to AO upon OC. I can just take this one. This first part you can take this one. Second part I am taking this one. Or you can just write this one as well. AM upon MD is equal to AO upon OC here, but in place of this AM upon MD, I can write DO upon OB, क्योंकि ये दोनों भी इक्वल है. So we can write ये दोनों इक्वल हो गए. So पहला हमने ये वाला लिखा, उसके हिसाब से सेकेंड वन. यहाँ पे हमने पैरेलल लिया हुआ है MO upon AB, पर यहाँ पे पैरेलल आपको लेना नहीं है. This would be third one. But from given, जो आपका given है उसके हिसाब से ये लिख रहे हो आप. From given, that what we can write AM upon DM is equals to OA upon OC. I can write like this because ये दोनों equal है, बराबर. So what we can write, this MO is parallel to AB. So इसके हिसाब से converse of theorem, उससे हम ये लिख सकते हैं converse of theorem से कि OM is parallel to AB. So हमने construction क्या किया, OM is parallel to CD, ये हमने construct किया हुआ था. OM is parallel to CD, but हमें मिला क्या, OM is parallel to AB. तो अगर ये दोनों पैरेलल थे और अब ये दोनों भी पैरेलल हो गए, इसका मतलब क्या हुआ, AB is parallel to CD. अब AB is parallel to CD हो गया, that means what we can write, वो this is the trapezium, क्योंकि trapezium में क्या होगा, one of the side would be parallel, hence proved. Is it clear or not? Hello. Okay. So up to this we are keeping for today, and you have to complete this exercise in your F&B. Now you can leave. Bye everyone. We'll meet tomorrow.